Hey guys, I'm going to show you 3 examples of different composite figures and different situations you might run into when solving problems of area of composite figures. So in the one you see down here, you kind of want to think, what shapes can I make this into that I know how to find area for? We don't have any kind of formula for area of an L-shaped figure. So instead, we're going to look and see what we can break this into. I immediately see rectangles. So I'm going to think of this as cutting it into 2 rectangles and finding the area of either rectangle, then putting them together. So when I start with this first rectangle, I know that I have my base and my height. When I look at my second rectangle, I see a height, but I don't have a base. So this little length of this part is missing. So because this is a horizontal line, I'm going to go ahead and check out the other horizontal lines in this figure. I see that this horizontal line is 5 centimeters and this horizontal line is 8 centimeters. So how can I use that to find my missing piece? Well, if I know the total part is 8 and I know the part that I'm not using is 5, then I can use subtraction to tell that my missing piece is 3 centimeters. And so you always want to connect it to the lines that are moving the same way. You can kind of see I'm missing another length. If this is 10, and now I'm using my vertical lines, and this length right here is unknown, we don't know what it is, then can we use the 3 to help us? Since these are all vertical lines, we should be able to be helped and be able to figure out what this missing piece is. So let's go ahead and see if we can figure it out. If this big line from the top to the bottom is 10, and I know that this piece is 3 over here, then I can go ahead and subtract those and figure out that this missing piece is 7 centimeters. I don't need that the way that I cut it up, but I'm going to show you a different way to cut it up in a little bit that might help. So what I'm actually going to do is label these rectangles with numbers. I'm going to call this shape 1, and I'm going to call this shape 2. And over here, I'm going to draw them separately so I can take a look at what I can see. I know this has a length of 5 centimeters, and I have a length of 10 centimeters.
To find area of a rectangle, you need the formula base times height. I'm going to build an equation to solve for area of this actual rectangle. I need to substitute with 10 times 5, and so I know my area is 50 centimeters squared.
I also need my little rectangle, and this is a 3 centimeter by 3 centimeter square, actually. Although it doesn't look like a square, these measurements tell me it is a square.
So I know that area equals base times height, and area equals 3 times 3, so area
equals 9 centimeters squared. When you're finding composite figures, areas, you need to take the 2 areas and add them together. So I know that if I take the area of my large rectangle, 50, and I add that to the area of the small rectangle, 9 centimeters squared, I can find the composite area as 59 centimeters squared. Sometimes I kind of circle the answers as I go because it's not my finished solution, but it's numbers that I need along the way, and then in the end I box my answer. So I'm going to show you one more way you could have done this. I'm sure you wouldn't have all chosen this way. So the other way would have been to simply break them into rectangles that look like this. So my first rectangle would have been a 5 by 7, so that would have been 35 centimeters squared. And then this one would have been 24 centimeters squared. And if you add those together, you also get 49 centimeters squared. So it doesn't really matter how you break it up, as long as you can see shapes that you could break it up into. Let's try a different one. You can tell immediately that we're not going to be able to just split this one up into rectangles. So I'm going to show you 2 ways I would break this up. The first way is I would just simply take off this or separate the top triangle from the bottom trapezoid. This is a trapezoid. You can see the 2 sets of parallel sides right there, which are our bases. And we could have used that to find the area of the trapezoid and then the triangle. I'm going to do something a little different. I'm going to actually break the trapezoid up into a triangle and a rectangle. And I'm going to find the area of 3 shapes instead of just 2. So one strategy that I have is that I just want to build these separately on the side and find their separate areas, and then I can combine them to figure out the composite area. So let's start with this top triangle. I know that it's telling me that this from here to here is 7, which to me tells me that the height of this triangle is 7. So I'm actually going to draw that in here, 7 centimeters, and I know that my height and my base meet at a right angle. Also, this length is going to be the exact same length as the bottom of this rectangle. So I can automatically tell that this is going to be 15 centimeters. And I'm going to go ahead and draw that over here. So for this triangle, I know my formula is area equals base times height, JK, half of the base times height. I got to look at that formula chart. Don't forget that half. It'll make a big mistake for you. So I know I'm going to plug in and substitute what's given to me. My base is 15 and my height is 7. So I'm going to go ahead and this is going to be the equation for this triangle.
Next I'm going to start by, I'm not going to take half of either of these because they're not pretty even numbers. So I'm going to go ahead and just multiply 15 times 7 to get 105. And then I'm going to take half of 105.
Which leaves me with 52 5/10 centimeters squared. I'm going to circle this because this is the area of my first triangle. Next, I'm going to look at this rectangle. I know my height is 8 centimeters and my base is 15 centimeters. So I'm going to bring over my formula, area equals base times height. I'm going to plug in my numbers and substitute. So I have 15 as my base and my height is 8. And I know that 15 times 8 is 120. So the area of this triangle is 120 centimeters squared. And I'm going to circle this as well. It's what I need to find my answer, but it's not my answer yet. So I have a right triangle here, and I can see that this is 9 centimeters, this base, and this height I have to bring over from the 8. It's the same congruent side. This is congruent to this. So I know this is 8 centimeters.
So for a triangle, I know my formula is half of the base times height. So I'm going to go ahead and plug that in this way. That's going to be half of 8 times 9. Then I'm going to go ahead and just take half of 8. Because it's a nice, pretty number to take half of, then I know that my area is going to be 4 times 9. And that is
going to give me an area of 36 centimeters squared. And I'm going to circle that, if it will let me. Okay, so now I have my 3 areas, and sometimes if you haven't written all over it the way I have, sometimes I actually write those areas in here just so I can visualize it a little better to see what it's talking about. I know this is 52.5 centimeters squared, or 52 5/10. I know my rectangle is 120 centimeters squared. And then this side right triangle is 36 centimeters squared. To find the composite figure area, I need to add all of these up. So I like to do it by placing the largest first. So I'm going to go ahead and say 120 plus 52 5/10 plus 36. I'm getting a little squished down here. And I need to add that up. I'm going to go ahead and line up my decimals and add some zeros there just to make myself feel a little better. And when I add that up, I get 208 5/10. So the composite area of this is 208 5/10 centimeters squared. And I'm going to box this because this is my end game answer. Let's try one more. This one's a little funky, and I wanted to show it to you because of all these amazing congruency marks. Anything with this single line is going to tell me, hold on. Anything with this single line right here is going to tell me that that's 4. So I know this is 4 meters. I know this from here to here is 4 meters. Anything even down here I know is 4 meters. So I'm going to use these congruency marks to help me along the way. But I am going to separate these out because I like to look at them separated just so I can clear my mind from this big shape we're trying to look at. So I'm going to go ahead and look at this right triangle. I'm going to pull it over here. And I know that these two, the base and the height, are actually congruent. And those base and height are 4. So I'm going to label those with 4s. And I know that it's 4 meters. Sorry guys, I know this is a little squished. Let me try to see if I can make it look a little better. So this is going to be a 4 meters, and this is 4 meters.
Area of a triangle is half of the base times height. So area is half of 4 times 4. I could take half of 4 and make that 2, and 2 times 4 is 8, but just to show it in a different way, I'm going to keep half and just go ahead and make 4 times 4 16, and then I'm going to take half of 16, which is 8. So this is going to be 8 meters squared.
And I'm going to go ahead and pop that in over here. This is going to be 8 meters squared. Now I'm going to draw my parallelogram. I know this is congruent, so this is 4. And what you may not notice, but the side length, the height, I need to build that height. The height needs to meet the base at a right angle, and if you notice, that is the exact same length as this side over here. So if I'm looking at these two as being congruent, then I know that I need to have that as a side length of 4 as well. So my height for this parallelogram is also 4. Notice here I'm actually bringing that height out to the side, which is fine, or you can draw it in the parallelogram.
Like I did in the picture. Area for parallelogram is base times height. So area for this parallelogram is just 4 times 4. So area is 16 meters squared.
So I'm going to go ahead and write that in here. This is a 16 meters squared. My last shape is a trapezoid. So this is called a right trapezoid because it has right angles. It has one set of parallel sides. The other set is not parallel. We have a little chopped off triangle. And so I need a new formula, and I'm going to bring this over here as well. There's my beautiful congruency mark that I love so much. So I know that that's 4 meters. I know the other base is 10 and 2/10 meters. And guess what my height is? You guessed it, 4 meters, because of that beautiful congruency mark. I'm going to go ahead and do the work for this here, but I'm going to have to squish it in.
Just a little bit. I'm going to make my pen a little smaller. So here we go. Area equals half of the base plus base 1 plus base 2 times the height. So I'm going to use my substitution to fill this equation in. Half of base 1, and it doesn't matter which base you use. I'm going to go ahead and use 10 and 2/10 plus 4 times 4. So area equals, and I'm not going to go ahead and add this. I think that's the best way to go because it's a grouping symbol. So that's going to give me 14 and 2/10 times 4. And then personally, I think the best choice is to take half of 14.2, which is, I'm going to go ahead and move over here, y'all. Area equals 7 and 1/10 times 4. And if you multiply 7 and 1/10 times 4, you get 28.4 and 28 and 4/10 meters squared.
I'm going to go ahead and pop that in here. 28 and 4/10 meters squared. So there's all the work. That's the work that I would expect you guys to show, which is why I'm taking the time to show it so you can see it. Now we need to find the composite area. So I found my 3 separate areas, and I'm going to put those together now to find my composite area. So I know that 28 and 4/10 plus 16 plus 8 is going to give me my answer. I just like to bring in my zeros here, so I'm going to go ahead and do that. I'm going to add it up. When I add those up, I get 52 and 4/10 meters squared. And that is going to be the area of this composite figure. I hope this was clear and that you guys have a better understanding of the different ways we might run into composite figures. Bye!